You're welcome once again to New Focused Approach to Mathematics Basic 8. This is the revised edition, and in this video we are looking at identifying perfect squares and determining their square roots. Now I want to identify perfect squares and determine their square roots. What is a perfect square in the first place? Numbers that are perfect squares, when represented by objects, can be arranged in a square shape without any objects left over. Okay, what it means is that, let me ignore one for the moment. If I give you objects like maybe counters, 4 of them, and I ask you to arrange them in a square, you get 2 by 2. What if I give you 5 of them? Then you are going to arrange them 1, 2, 3, 4. The 5th one would not make this shape look like a square. So 5 cannot be a perfect square number. If you try 6 the same way, 6 can go 1, 2, 3, 4, maybe 5, 6. It will be a rectangle but not a square. If you try 7, it won't work. 8 won't work. But 9 can give you 3 by 3. It will arrange itself as a perfect square or as a square. Then 16 can do the same thing. 15 cannot. 14 cannot. Then 25 can also do the same thing. And so these numbers that can arrange into a square shape without any object left behind, they are what we call perfect square. Now 1 also is a perfect square, though 1 is just a 1, and we can just keep it as a square for now, and you will understand why I'm saying 1 is a perfect square. Okay, now you realize also that this number, which is 4, was arranged 2 by 2, so 2 by 2, and that is 4. Here was also arranged 3 by 3, so 3 by 3. And when you say 3 times 3, you say it's 9. 4 by 4, okay, will give you 16. And 5 by 5 will give you 25. And you can predict the next number that will come. What would that be? Well, 6 by 6. And so 6 by 6 will give us 36. And those are also perfect squares. Now, so if you take 1 and you square it, you still get 1. And that's why we want to add 1 as a perfect square, right? If you take 2 and you square it, or 2 times 2, which is 2 squared, will give you 4. 3 times 3 will give you 9. 4 will give you 16. 5 will give you 25. Good. 6, 36. 7, 49. Good. 8. 8 times 8, 64. Good. 9 times 9, 81. And then let me add 10 by 10, also making it 100. Now you need to know all these numbers. All these numbers we see here, they are what we refer to as perfect square numbers. Perfect square numbers, right? Perfect square numbers. Now, if I continue these numbers and I go, we did up to 10, okay? If you go by 11, you get 121 as a perfect square, 144 as a perfect square, 169, 196, up to 32 squared, which is 1024. These are perfect squares, right? Okay, so before we continue with perfect square again, I want to introduce another concept we call square root of a number. There is this symbol we call radical. I'm sure you might have seen it. We normally refer to as square root symbol, maybe square root of 9 and so on and so forth. So we call it square root, but then in actual sense it is called radical. The symbol is called radical. Now that symbol represents taking the second root of a number. We can take the third root of a number and put a 3 here, fourth root, fifth root, and so on and so forth. But for now, second root of a number, which we call square root, we use the symbol radical to represent it. A number that goes under radical is called radicand, and the symbol is called radical. Right. Now what we are going to use this particular symbol radical to take square root of a number. Now what it means is that if I have every perfect square number like 4 and I take square root of that 4, it means I'm taking the second root of it. What number times 2 or times itself twice will give me the 4, which is 2. And so square root of 4 is 2. Square root of 9 will be 3, because 3 times 3, which is the same as 3 squared, is 9. So the second root of 9 is 3. Now, you can also observe that if we keep adding odd numbers, we'll be generating perfect square numbers. So 1 is 1, 1 plus 3 is 4, 1 plus 3 plus 5 is 9, 1 plus 3 plus 5 plus 7 is 16, in that order. So you can even predict the next perfect square number, which would be all this plus 15, and that will give us the next perfect square number, which will be 64. Good. Now, how do we find square root of a given square number? How do we find square root of a given square number? We've realized that if we add consecutive odd numbers, we always generate a perfect square number. And so if I want to take the square root of a perfect square number, for example, I want to take the square root of 36, I can continuously subtract odd numbers from 36. So let me start with 1. If I subtract 1 from 36, I'm going to get 35. The next odd number will be 3. So subtract 3 from this number, I'm going to get 32. The next odd number will be 5. Subtract 5 from this number, I'll be having 27. The next odd number is 7. Subtract 7 from this, I have 20. The next odd number is 9. Take 9 from here, I have 11. The next odd number from 11 after 9 will still be 11, and so that will give me 0. Now the moment I do continuous subtraction and I get to 0, of course I always get to 0 because that it was the odd numbers sum that gave us the perfect square. So when I get to 0, I ask myself, how many times have I done this subtraction? The first one was here, 1, 2, 3, 4, 5, 6 times. So if it is 6 times, then the square root of 36 will be equal to 6. That's how we can use subtraction of odd numbers to generate the square root of a number. So we can do this with all other odd numbers, so all other perfect square. But then in a very simplest way, if you want to know square root of a perfect square, let's say 49, then ask yourself, what number times itself will give us 49? And you see that you get 7 times 7, that will give us 49. For that matter, root of 49 is 7. Root of 49 is 7. So what will happen for root of 100? Of course, it will be 10 times 10, so root of 100 is 10. What is root of 81? So that will give us 9, because 9 squared is 81. I'm sure this has given you a fair idea about what perfect square is and what square root of a number is. Thanks so much for watching.